Whoa! It's unit 2.10. Action and reaction. In this unit, we'll be learning about Newton's third law. Newton's third law states that for every action, there is an equal but opposite reaction. This means that when you push a wall, the wall is actually pushing back. That punk. Anyways, yeah, everything will push back. Nothing will just sit there and take it like some sort of slave. They'll fight back. This is the natural force of the world. You push a table, it'll push back. You push anything, it'll push back. That's just how it works. Action exists in pairs. When you push the ground on a skateboard, the ground pushes you back. This is where you move forward. Or when you shoot a gun, the bullet travels forward, but the gun gets kicked back. You know why they call it action and reaction? It's because action, and then you get a reaction. Exactly. Mind blown right there. So yeah, the action exists in pairs. There are many more of these. For example, when you jump, you actually push the earth, but you push it very slightly because you're very weak. But if everybody on the earth jumps at once, it will actually push the earth by, again, not much, but it's something. Example, a fan pushing air. It's due to the shape of the fan's fin, it will rotate and then push air forward. But as a reaction, the air will also push back on the fan. But because the friction on the ground against the fan is actually stronger than the force of the wind, it will not move. So it will just blow air onto you. Another example is planes. Planes use this law to its advantage. It uses in the engine of the plane, there are huge turbines which rotate very fast. This causes air to get pushed back. Due to the law of physics, air pushes back on the plane. This causes the plane to move forward. It's just like the fan, except it's a plane. Alright, this method only works with an atmosphere. Without air, there is nothing to push against. So, how do spaceships work in the vacuum of space? Before we answer that, let me clarify the planes. Planes, they push forward using the fans, right? So, for example, in fans, when you rotate, the air will push against it back. But due to the shape of the plane's fin is different, so it's like inverted. So it'll or they can rotate it the different way, and so the air gets pushed back and it will push the plane back. So it's like, whoa, it's crazy. Alright, rockets. This is how spaceships work in space. Rockets use action-reaction principle. A rocket thrusts itself by pushing out huge masses of air very quickly. When you push the air pushes back. This causes the rocket to get propelled. As you can see, they pump air in here, and then they pump oxygen, nitrogen or something, and then they light it up. Boom! Explode, and they just... Alright. Jets also use this, but it's a mixture of both of these methods. It's a hybrid engine. It uses some fuel and some air to move very fast. As you can see, there's a turbine which lifts lots of propellers right here. Here's the fuel. It's like this. It's this mixed with the turbine. So the turbine is up here, they mix the fuel here, they ignite, and then poof, they push the air out right there. So with the force of the reaction right there, and also with the force of air coming in front, it can move very fast indeed. Alright, that's it. I'm done. Yet again, I barely reached 5 minutes. I just want the marks. I need the marks.